Good evening. Am I audible? Can anyone message me? Am I audible? Can you mention in the chat box? Is my voice audible? Yes. Okay, then I will start the session. Today we will discuss about electricity bill. So, as the title that I mentioned here is power rating of electrical appliances. So, how to calculate the electricity bill that we will discuss today. So, before discussing how to calculate the electricity bill, let us see how electrical power is generated. So if you see in this image, so this is the power plant which generates the electrical energy. Okay, so I will take the highlighter. Okay, this is the power plant which generates the electrical energy. Yes, this is the power plant which generates the electrical energy. Whatever power that is generated here in this power plant, that is given to a step-up transformer. So this here you can see transformer steps up voltage for transmission. So here it is given to the step-up transformer. This is a step-up transformer. So it will increase the voltage level without changing any frequency, and that is transmitted through the transmission line. So transmission line carrying electrical electricity for long distance, they have mentioned here. So this is a tower. So then as soon as this after transmitting electrical energy nearby to the load sector, wherever the load is there, step down transformer is connected. So nearby transformer steps down voltage. Nearby means, sorry, not nearby, neighborhood. So neighborhood means the transformer which is nearby to the load. Here you can see a house. So this house resembles the load. Okay, house is nothing but the load because we need electrical energy. Okay, in our daily life, we need electrical energy in our houses. We definitely use electrical energy for many purposes. Okay, we are in need of electrical energy. So, for many applications, we need electrical energy. So, house is the load. Okay, so here house is the load. So, nearby to the load sector, whichever transformer is connected, it is a step down transformer. So the voltage level is stepped down nearby to the load sector, and that is given to the load. Load means here, just for example, we are considering a house here. Okay. Now, so electrical energy is generated. Okay. So electrical energy is generated, then it is transmitted. After that, it is distributed to the load. Here I have shown you only one house. We know many houses will be there. Okay. And we know not only houses require the electrical energy, industries require the electrical energy, every institute requires electrical energy. So this electrical energy is distributed to various loads. Okay, so the load can be a house, it can be an office, it can be an institute. Okay, it can be any commercial building, or it can be an industry. Okay, it can be a factory. Okay, so that's what the title. If you see here, electricity generation, transmission, and distribution. So electrical energy is generated, then it is transmitted, then it is distributed to various load sectors. Today we will mainly concentrate on only one load, that is domestic load. Domestic load means our houses. We will concentrate more on our houses. I have one more image in the other slide. So in this slide, if you see, this is the power plant where electrical energy is generated. Okay, so here electrical power is generated. After that, this electrical energy, whatever is generated, it is transmitted. Okay, it is transmitted, and there will be in between, before reaching the load, in between there will be some substations. See, at the generating station, nearby to generating station, and in between also there will be some substations. Okay, so we did not discuss. There is no need to discuss about substations because our concept is to calculate the electricity. I'm just briefly, I wanted to discuss how electricity is generated and how it is, um, so where it is generated and it is transmitted. It is generated, transmitted, and distributed. That's what I wanted to discuss because it is not our concept now. So power is generated and it is transmitted and it is given to the distributed to the different load sectors. So here, that's what happens. So power system, we will call it as power system. Power system consists of generation, transmission, and distribution. So after this electrical energy that reaches the household houses, so in the houses we have different household appliances, electrical appliances. Okay, in our houses there are different electrical appliances. So here you can see we might have coffee makers. We definitely in almost every house there will be blenders and mixers, toasters, crock pots, rice cookers, pressure cookers, electrical stove. This is an electrical stove. Okay, we may have kitchen hoods. Okay, in our houses, lamps will be there, light bulbs will be there. Okay, lanterns which are operated with electrical energy and what is a rechargeable torches. Okay, so the many appliances are shown in this image: tea makers, kettle, electric drilling machine. Okay, this is a drilling machine, water cooker. Okay, this is an oven. This is kitchen hood. This is dishwasher. Okay, this is a clothes dryer. Okay, so these are the speakers which we connect to some. Okay, we connect them to usually to the television. Okay, electric guitar, electric fan, and vacuum cleaners. Okay, so of course, these are some of the household appliances which we use in our houses. Okay, so all these household appliances, yeah, all these household appliances which we use in our houses, they will not consume same electrical energy. The energy consumed by these household appliances will not be same. Okay, so each household appliance will have its own power rating. Okay, each household appliance will have its own power rating, and that power rating will be mentioned in a small slip on the household appliance when we buy. Okay, we will usually purchase the household appliance. Just for example, if you see, uh, here I have mentioned power rating of household appliance. So here I am showing you an air conditioner. Okay, on the air conditioner, you can see at the top right, there is a small red yellow color sticker. In your houses, you can observe that. Okay, so usually there will be a red yellow color sticker that is on the maybe on the right side or left side of your air conditioner. Okay, and on that sticker, if you carefully observe, so this is the sticker. So this is the larger view of the sticker. On this sticker, if you carefully observe, you can see the its rating. Okay, you can see the power capacity is given here some 6,000, 2,500 something here. They have written in watts. Okay, cooling capacity 100%, cooling capacity 50%. That's what they have mentioned. LCD consumption they have mentioned here. This is LCD consumption. Okay, that is around 744.54 units per year. Okay, so the power rating, so how much power these electrical appliances will consume. Okay, that will be usually um, mentioned at some location. When you buy the electrical appliance, you just carefully observe. I have few more images. See, this is also an compressor of the air conditioner. Here it is mentioned air conditioner. So this sticker. So you can see this sticker. If you carefully observe somewhere, its voltage is its volts. You can see some 208 to 330 volts. Frequency is mentioned 60 hertz frequency. So in Indian standards, frequency is only 50. But this is, I think, this image is this compressor belongs to some foreign country. So here it is mentioned Canada. Okay, here if you see, you can see Canada. So its current ratings will also be mentioned in, okay. So here it is also mentioned USA and Canada. So I think this compressor belongs to USA or Canada. Okay. So how much voltage it will consume is mentioned here. So usually even manufacturing date is also mentioned. By 2021 it is mentioned here. Okay. So whatever electrical appliance that we buy, there will be rating. The rating of that electrical appliances will be provided. There will be a sticker somewhere on the electrical appliance. If you carefully observe, you just check for the ratings in your houses. Okay, I have one more image. You see here. Here, this is an air cooler, and you can see back side. Here, one line. This line, if you observe, it is this sticker is on the back side. It's voltage, frequency, and power ratings are provided here. So, rating of an electrical appliance indicates what? It indicates the voltage at which the appliance is designed to work and the current consumption at which that voltage. Okay, current consumption for that particular voltage. Okay. So power rating of the household appliances, those ratings, they indicate the voltage at which the appliance will operate. Okay, or the appliance is designed to work, and how much current that this appliance will consume while operating. For example, I have one more image. If you see here, where is my cursor? Ah, yeah, it is here. So if you see here, the voltage that this is going to consume is around 208 to 240, and how much current that is voltage for which this what is this? This is a coffee brewer. Okay, so the voltage that this the voltage at which this device will operate is around 240. 208 to 240 as mentioned, and current that this device is going to consume, or this coffee brewer is going to consume, is around 19.5 to 25 0.8 amperes, and its power rating is 4.9 to 9.1, and it can operate for both single phase and three phase. Okay, so even heater, its heater rating is also provided, 3 into 3 kilowatts. Okay, so it is made in USA in the year of 2003. Okay, these sort of stickers are available on the electrical appliances that we buy. Okay, so the power rating of this appliance is related to the power that this device will consume, or household appliance will consume. Every electrical appliance has a power rating which indicates the amount of electricity required to do work. Okay, so every electrical appliance will have power rating. That power rating indicates that the amount of electricity required to work. So this is usually given in watts. Power rating is usually given in watts or in kilowatts. So here you can see in kilowatts, isn't it? This is the power rating. It is given in kilowatts. Okay, so have some list. So if you see here, if we are using light bulbs, in incandescent bulbs, nowadays nobody is using incandescent bulbs. If incandescent bulbs are used, their power rating will be usually 60 watts, 80 watts, or 100 watts. Okay, if we are using electric steam iron, its power rating will be 2400 watts. If you are using standing fan, its power rating will be 70 watts. If we are using water heater or kettle, its power rating will be around 2000 watts. If we are using electric blender, its power rating will be 350 watts. If we are using refrigerator, its power rating will be 200 watts. If we are using microwave, its power rating is 1200 watts. If we are using hand dryer, its power rating will be around 1800 watts. Okay, so these power ratings, you can know about this power rating simply whatever electrical appliance that is available in your houses, you just look around it. Okay, somewhere At some corner of the device, there will be a small sticker. On the sticker, these ratings will be provided. Now, when we have an electrical appliance, okay, so we know just now I have mentioned that they will have some power rating. So, till now, based on whatever I have discussed, we have understood that each electrical appliance will have its own power rating. Okay, so power rating of all the electrical appliances may not be same. Okay, so power rating may not be same, so they will have their own power rating. Now, all these electrical appliances uh, which we use in our houses, okay, they are not operated for the same interval of time, isn't it? For example, if you take a washing machine, here I have mentioned power rating is 1.4 kilowatts. It is operated for around 1 to 3 hours, isn't it? It is operated for around 1 to 3 hours. Similarly, if we consider a dishwasher, its power rating is 1.32 and it is operated for around 1 to 3 hours. Similarly, if we take a hair straightener, its power rating is around 0.0055 kilowatts and it is operated for 1 to 2 hours. Okay. Similarly, hair dryer, its rating is 1.8 kilowatts and it is operated for 1 to 2 hours. Similarly, microwave, its power rating is 1.2 kilowatts. It is operated for 3 to 5 hours. If you use a computer, its power rating is very low. See, when compared to others, it's low, 0.15. Of course, when compared to hair straightener, computer power rating is more, but it is only 0.15 kilowatts and it is operated usually for longer period of time, around 6 to 12 hours. Okay. And similarly, if we have an oven, its power rating is 2.4 kilowatts. It is operated for 1 to 3 hours. These are the approximate usage hours, you know. These hours may vary. If we have an electric iron, its power rating is 2.4 kilowatts. It is operated for 2 to 4 hours per day. Okay. If we have a toaster, its power rating is 0.8 kilowatts. It is operated for 3 to 5 hours. If we have an electric kettle, its power rating is 2 kilowatts and it is operated for 1 to 2 hours. Okay, so these are the approximate values, not the exact values. Exact power ratings, depending on the company. See, there will be different companies. They manufacture these devices, and we usually, whichever company we prefer. Just for example, washing machines are available. You can buy LG company washing machine or Samsung or there are many, isn't it? I need not mention all those companies names here, but there are different, and they're based on their capacity, their power rating may vary. Okay, and their operating time may also vary. So all the devices, depending on the manufacturer, their power ratings may vary. So whatever I'm showing you here, they are not the fixed values; they are approximate values. So all the electrical appliances, till now, whatever I have discussed. From that discussion, it is understood that all the electrical appliances will not have same power and they are not operated for the same interval of time. Okay, so the duration for which they are operated will vary from person to person, from uh, from one house. In one house, they may operate washing machine 2 times per day. So this time will vary from 3 to 6 hours, isn't it? So if we some people they may wash dishwasher or some people may use dishwasher, okay, uh, okay, or some may not use dishwasher, so they will not even buy it, okay, and depending on the company and requirement, the number of hours used. For example, if we take computer, some people may use the computer only 2 hours per day. Okay, some people may continuously sit for 6 hours and very rare case, okay, it's a rare case to sit continuously in front of the computer for 12 hours. Of course, with certain short breaks, some person may continuously sit for, not continuously, with short breaks he can work per day, he can work for 12 hours, it depends. Okay, so if what is power, we already know power is V into I. So current into voltage I have written here. So P is equal to I into V. So power units is watts, current units is amperes, and Voltage units is volts. So if I want to mention 1 kilowatt in watts, 1 kilowatt in watts, kilo means 1000. So 1 kilowatt is nothing but 1000 watts. Okay, 1 kilowatt is nothing but 1000 watts. Okay, is there any disturbance? Can anyone mention in the chat box? Any disturbance? Yes or no? Y or N? Just type Y. There is any disturbance? If no disturbance, you can type N in the chat box. At the end of this session, I will forward the link in the chat box. You people can. Okay, no, okay. So at the end of the session, I will forward the link for attendance. You people can just fill the Google form and submit. So now let us see energy consumption calculation. How to calculate the energy, electrical energy that is consumed in our houses. Okay, so of course we'll discuss about the houses later. So let us see how to calculate energy consumption calculation. So electrical energy consumption of any device is calculated by simply multiplying the wattage. Okay, so just now I told you when we buy an electrical device, its wattage will be mentioned on the device. Okay, so energy consumption of a device is calculated by multiplying the wattage of the device and operational hours. So to make it more simple, I have written in terms of equation here. So what is energy consumption? Electrical energy consumption is wattage into operational hours. For how many hours per day you are operating. Okay. So energy consumption formula is what? Wattage into operational hours. If you want, you can note down this. Just I will wait for a few seconds. You can note it down. You can note it down if you want. So I hope you have written. So let us proceed. Energy consumption is what? Wattage into operational hours. So now if the electrical energy that is consumed by this electrical appliance is calculated in terms of kilowatt hour, okay, kilowatt hour, then that is known as unit. Okay, so what is unit? Definition of unit is the electrical energy consumed in kilowatt hour. Okay, so in previous slide, if you see, if this is wattage W into operational hour, WH. So energy consumption is what? WH. W into H. So what is unit? kWh. What is K? Kilo. Kilowatt hour. So kilowatt hour is nothing but the unit. So that's what I have mentioned here in terms of equations. Kilowatt hour is what? kW into time in hours. H is what? H is time in hours. Okay. So my cursor is very sensitive. What is this H? It is time in hours. Okay. So 1 kilowatt hour is what? 1 kilowatt into 1 hour. 1 kilowatt is 1 kilowatt into 1 hour. 1 kilowatt hour, you can write it as 1 kilo means 1000. So 1000 watt into 1 hour. Okay. And 1000 watt into 1 hour, you can write it as how much? 1000 watt hour. So 1 kilowatt hour is 1000 watt hour. So 1 kilowatt hour means what? Just now I mentioned earlier. 1 kilowatt hour is nothing but our unit. So 1 kilowatt is 1 unit. So 1 kilowatt hour is 1 unit. 1 kilowatt hour is 1 unit. You can write it down. You just note it down in your notes, and if you complete, just mention in the chat box. Just type C so that I will proceed. So I will just take the class for approximately 1 hour. That's it. I will not extend beyond 1 hour. I will try my best to complete within 1 hour. Completed? Okay. Okay then. Now, 1 kilowatt hour is what? It is the electrical energy consumed by the electrical appliance. Okay. So of power, how much power? 1 kilowatt, and it is used for how much time? 1 hour. Okay. So that you can mention like this: 1 kilowatt hour is equal to 1 unit. That is equal to 1000 watts per hour. That is equal to 1000 watts per hour. Okay. So you need not write it. I have already discussed this. So 1 kilowatt hour is equal to 1 unit. 1 kilowatt hour equal to 1 unit. That is equal to 1000 watts per hour. Okay. So for example, I'm showing you this image. In this image, you can see a lamp. Okay. There is a lamp. Okay. Its wattage is 100 watts. Wattage of this lamp is 100 watts. Okay. And it has been operated. It has been used. The lamp was turned on. For how much time? 1 hour. Okay. For 1 hour, that lamp was turned on. Okay. Now, what is our wattage, watt hour? Okay, energy consumption. How much energy is consumed here? 100 into 1. How much energy consumed is what? Wattage into hours, operational hours. So here 100 watts into 1 hour will give us 100 watt hour. Okay, that is the energy consumption. Okay, 100 watts into 1 hour equal to 100 watt hour. That is the energy consumption. I have one more example. So here again I have taken a lamp. The lamp rating is 1 watt. Okay, and it is operated for 1000 hours. So this lamp is operated for 1000 hours. Okay, then what is the energy consumed here? 1 kilowatt hour. Okay, 1 kilowatt means 1000 watt hour. Okay, so 1 kilowatt is watt hour is equal to 1 unit. So 1 unit is consumed here. Okay, so I have one more example. Here one lamp is there whose rating is 100 watts, and it has been operated for 9 hours. Okay, lamp was turned on for 9 hours. After 9 hours, switch was turned off. So rating of the lamp is 100 watts, and it was operated for 9 hours. So what is the energy consumption? 900 watt hour. If you convert that into kilowatt hour, divide it by 1000, 900 by 1000, you will get 0.9 kilowatt hour. Okay. Similarly, if we have more than one lamp, let us assume there are 3 lamps. Okay. Rating of each lamp is 100. So 100 into 3. Okay, we have 3 lamps. Each lamp rating is 100. So total wattage is how much? 3 lamps. So 300 watts. Total wattage of these 3 lamps is 300 watts. Okay. Total wattage of these 3 lamps is 300 watts, and they have been operated for 3 hours. Okay. These 3 lamps are turned on and kept in on position for 3 hours. So how much power is consumed? Energy consumption is 900 watt hour. Okay, if you convert that into kilowatts, divide 900 by 1000, you will get 0.9 kilowatt hour. Okay. So I have one more example. See here, These are the electric chargers, electric vehicle chargers. So electric vehicle charger, this electric vehicle charger rating is 7.5 kilowatts, and this electric vehicle charging, power rating is 60 kilowatts. So power rating of this electrical vehicle is, electric vehicle charger is 7.5. Okay, this electric vehicle charging device is 60 watts. So kilowatts is the power consumed. So how much energy consumption here? Okay. So for if they are operated, if they are charging a car, okay, this electric vehicle charger is charging a car for 2 hours. Its rating is 7.5 and it is charging the electric car for 2 hours. Okay, then 7.5 into 2, you will get 15 kilowatt hour. Similarly, this electric vehicle charger, my cursor is sensitive on it. Okay, so this electric vehicle charger, it is charging the car for how much time? 2 hours, same 2 hours only. It is charging the electric car for 2 hours and its rating is how much? 60 watts. Rating of this charger, electric vehicle charger is 60 watts. So how much is the energy consumed? 120 kilowatt hour. Okay. So power is measured in kilowatts and energy is measured in what? Kilowatt hour. Okay. So now let us see the electrical energy consumption for our houses. So calculation of power consumption of electrical appliances in our houses. Okay. So now this can be represented, energy consumption in our houses can be represented in a flow chart. So steps for energy consumption calculation. So steps that are to be followed. Step 1 is 1A. If power of appliance is given, okay, some 60 watts for example here mentioned. Step B, if the power of appliance is not given, but voltage and current are given. Okay, so on some devices, okay, on some electrical devices, wattage, the watts will be given. On some electrical devices, voltage and current are given. If voltage and current are given, we have to calculate the power. P equal to V into I. Okay, if voltage and current are mentioned, then we have to calculate the power. If directly power value is given, we will note down that. So convert watts into kilowatts. Second step, step number 2. Step number 2 is convert watts into kilowatts. So watts is to be converted into kilowatts. Simply divide by 1000, you will get kilowatts. After that, step number 3. In step number 3, find the energy consumed in kilowatt hour. Okay. So energy consumed in kilowatt hour. For that, what we have to do? Wattage into time of operation. For how many hours it was operated, we have to mention. Here T represents time of operation in hours. Okay, time of operation in hours. Okay, so E equal to P into T. So wattage into time of operation. Next step number 4 is multiply by unit cost to find the total cost. So whatever per unit cost is there here, for example, he has mentioned some 0.194 per kilowatt hour. So whatever per unit cost is there, with that we have to multiply the energy consumed. So let us see that step by step. This is just for an example. I have shown you this flow chart here. Let us do that step by step. Okay. So let us consider different home appliances to calculate the approximate total energy consumption of house per month. Per month means so in 1 month there may be 30 days. For 1 month, for other month there may be 31 days. Here what we are going to do is we are going to take an example of 30 days. Of course, I'm not going to calculate the electrical energy. I will just show you the steps that are to be followed to calculate the electrical energy consumption. Okay. So let us see the step 1, home appliances with ratings. So these are the household appliances and their ratings in watts. Okay, so these ratings you can find out from the sticker that is pasted on some, usually maybe in front or back, somewhere at some location of the electrical appliance that you buy, there will be a small sticker on which the ratings will be provided. So you can note down those ratings. Okay, just for example, I have just enlisted some of the ratings of the household appliances. So these are some household appliances. Okay, whose power ratings I have mentioned here. Okay, no need to write down these ratings now. So few more. Okay, so household appliances, whose ratings I have mentioned here. Now, step number 2. Step 2 is to calculate the power consumption of electrical home appliance per month for 30 days. So for that, first of all, I have drawn a table. This table may be familiar to you people. Okay, so first of all, we will write down all the appliances, household appliances that we use in our house in the first column. Okay, in the first column, we will write down all the appliances, and in the second column, we will write the power rating of each appliance. Okay, power rating for ceiling fan, power rating is 120 watts. Okay, and for incandescent bulb, its power rating is 100. Electric shaver, its power rating is around 15 watts. So we can write down many appliances. So I think this table is familiar to people. Next, quantity, number of appliances. Okay, here I have mentioned four. Four means in my house, for example, if there are four fans, so that's why I have written total four number of quantity of the equipment means number of fans or incandescent bulbs or electric shavers. We can write on this third column. Then number of hours of usage per day. In one day, for how many hours we will use these electrical appliances. Just for example, ceiling fan, we may use per day, we may use them for 6 hours or 8 hours. Some people may use more than 12 hours. Okay, so those who stay in the houses for 24 hours, at least some people they won't even turn off the fan. So they may use for approximately 20 hours also. Some of the people. Okay, so for how many hours per day they are using in 24 hours? How many hours they are using? That we have to mention. Here I have mentioned 6 hours per day. Okay, here it is per day usage. This is per day usage. Next, energy consumption per day we have to calculate. So for energy consumption per day, formula is wattage into number of units into number of hours operated. So wattage is 120 here, just for example, and number of how many number of fans are there? Four. How many hours these four fans were operated is 6. So you just multiply all these. What do you get? Energy consumed per day. Okay. So if I want the energy consumed per month, so multiply energy consumed per day with 30. Okay. So approximately, let us consider per month there are 30 days. So you just multiply this energy consumed per day with 30. Okay. So for all the appliances, you calculate at the end total energy consumed per month in our house. You calculate that. So you have to add all these. Okay, all the household appliances energy consumption per month, whatever you get, you have to add them. You will get total energy consumed per month in watt hour. Okay, total energy consumed per month in watt hour you will get. After that, step number 2. This is step number 2. After that, let us go to step number 3. Okay, let us go to step number 3. So step number 3 is calculation of the total energy consumed per month in kilowatt hour. So just now we have calculated in watt hour. Now we will convert that into kilowatt hour. Simply what you do is you just convert that into kilowatt hour. Okay. For that, what you have to do is here. Okay. Simply whatever wattage that you have got. So if you multiply with 1000, you will get in kilowatt hour. Okay, you can multiply in thousand with 1000, or but you have only what to say. What I will do is I'm going to divide with 1000. Okay, I'm not going to multiply here. I'm going to divide with 1000. Okay, to convert that wattage into kilowatts. So divide with 1000. So here I have multiplied here. Okay. So if you multiply, the quantity will become even, the magnitude or the watt hour value, energy consumed value will become very high value. So just divide with 1000. So convert that into kilowatt. So now whatever energy that you have consumed is now in kilowatt hour. So total energy consumption per month in kilowatt hour. Total energy consumption per month in kilowatt hour is this. So you just divide that by 1000. And we know, we have already discussed 1 kilowatt hour equal to 1 unit. Okay. So whatever you are going to get here, total energy consumed per month in kilowatt hour. So you just, instead of writing kilowatt hour, you just write units. Okay. Total energy consumed per month in kilowatt equal to what? Number of units consumed per month. Okay. Total energy consumed per month. Whatever value that you are going to get. Okay. So instead of writing kilowatt hour, you just replace that term kilowatt hour with units. That's it. Nothing else. You need not do anything. Simply instead of writing kilowatt hour besides to the number that you have got, you write units. That's it. Now let's go to step number 4. Now let us calculate the cost based on the domestic tariff. So here I have written some approximate values. So if you get the energy consumed in units as it is, that unit, if the energy consumed per, in units lies between 0 to 100 units, then let us then the approximate cost, okay, let us assume it is 4. If it lies between 100 to 300, cost is 5. If it lies between 300 to 500, cost is 7. These are the approximate values, not exact. If it lies between 500 to 700 units, the cost is 9, and if it lies between 700 to 1000, the cost is around 10. So I got some, I just collected some information from the internet. So for domestic consumers, if their consumption is less than 500 units, okay, then this is the, sorry, if the consumption of the domestic people, we consume less than 500 units, then this is the existing cost and this is the new cost. Okay, so 0 to 100 they are not charging. Okay, less than 100 units they are not charging, but there will be minimum charge. If the consumption is 100 to 200, per unit cost is 2.25, and 200 to 400 units means 4.5, 400 to 500. This is above 500 units. This is the cost of usage. Above 500 units means, see, for 100 to 400 it is 4.5. Okay. So depending on number of units that you consume per month, the cost of usage will vary. Okay. So this is some data I collected from the internet. So I'm just showing you that. Now, the cost of number of units per month of our in our residence based on the domestic tariff. So this is domestic tariff, actually existing tariff or new tariff. Okay. So is will be equal to number of units consumed per month into per unit cost. Okay. So if you were unable to understand, let us solve some numerical problems and let us try to understand the concept. So write down this numerical problem. I'll just give you a minute. Write down this quickly. Write down this question quickly. If you complete, mention in the chat box. So whatever we have discussed, how to calculate the electrical energy consumption in with these numerical problems, we can you will be able to understand. Okay. So in this problem, here, okay, an electric iron, where is the cursor? Electric iron with the heating element of resistance value is given. Resistance is around 60 ohms, is connected to 240 volts supply. Mains means supply. Okay, and we have to calculate the electric power produced in the heating element and the amount of electrical energy consumed when iron is used for 20 minutes, and cost of the electricity given as per the Indian standards with power charging rate is given around rupees 0.194 per kilowatt hour. So we have to calculate all this. So if you have completed, just mention C in the chat box. Okay, okay, let us proceed. Already it's getting late, isn't it? I will try to complete as early as possible. Now, the power consumed. Okay, so they have asked us in there are three options A, B, C. So electrical power produced in the heating element means how much electrical energy power that has been consumed here. Let that we are calculating. Power formula is P is equal to V square by R. Voltage, they have mentioned voltage. How much voltage did they mention in the numerical problem? In the question, if you see, it is 240. So 240 square by R value, it is mentioned 60. So 240 square by 60, you will get 940 watts. So convert that into kilowatts. I'm sorry, you will get 960 watts, not 940. Sorry, it's 960 watts. 240 whole to the power of square by 60. So you will get 960 watts. Just divide by 1000 to write it in kilowatts. No need to convert that in kilowatts if you are not interested. Okay. But to calculate the energy consumed, okay, if you want to calculate the cost, then better to convert the power in watts to kilowatts. So did you write? Did you complete? Did you complete? Shall I proceed? Yeah. Okay, I hope you have written. Next. So amount of electrical energy consumed. Okay, amount of electrical energy consumed. Uh, amount of electrical energy consumed when iron is used for 20 minutes, he has mentioned. So how much power that has been consumed? Power that has been consumed, how much? It is 0.96, that is in kilowatt hour into 360 by 60. Okay, into 360 by 60. Why 360 by 60? Why? Because they have mentioned only 20 minutes. 20 minutes means Okay, you have to convert 20 minutes into hours, isn't it? So for one revolution, it is around 360, isn't it? One whole revolution is 360. Okay, and from 12 to 20 minutes means 12 to 4. 12 to 4 is it 12 to 4? Oh, of course. Here 1 hour. Okay, forget about 12 to 4. It is 1 hour. So for one revolution 360, and if you operate for in 1 hour, how many minutes are there? 60 minutes are there. So 360 by 60, you just write 360 by 60 and just divide, you will get some 6. Okay. So we are simply converting here our hours into minutes into hours. So I think I did not consider 20 minutes here. I have considered, I didn't consider 20 minutes. Okay, even though in the question they have mentioned 20 minutes, I didn't consider 20 minutes. It's okay. So whatever you can convert, you know how to convert minutes into 1 hour means 60 minutes. 20 minutes are there, 20 minutes, you convert that into hours. Okay. And you just multiply it with 0.96. So you can write it in the chat box here. I think I didn't follow the question. Okay. So 1 hour means 20 minutes. So I'm sorry. 1 hour means 60 minutes. I'm thinking something else. So 1 hour means 60 minutes. So 20 minutes, you just convert it into 60, convert it into hours. So 20 by 60. Okay, 1 by 3 you will get. So 0.96 by 3. 0.96 by 3, you will get the amount of electrical energy consumed. Okay, you will get the electrical energy consumed. So it is 0.96, 0.96 into 20 by 60. Okay, so here I did not consider for what to say. I did not consider 20 minutes. I think I have considered for um, 1 hour, 6 hours. That's why. Okay, I didn't read the question properly. So whatever, leave it. So okay, you just 0.96 by 3. I don't know how much you are going to get. If you have calculated, you can mention in the chat box 0.96 by 3. Okay, that is our energy consumption in kilowatt hour. Now, cost of electrical energy consumption. Okay, cost of electrical energy consumption. So here. So what is 0.96 by 3? Can anyone mention in the chat box? Calculate. Yeah, 0.32. Yeah, it is 0.32. So it is, I will just change it here. Sorry, I wanted to erase, but I don't. So this is 20. This is 20. This is 16. So what do you get? 1 by 3 you will get. Copy and here paste. So this is 1 and this is 3 and so here you will get 0.32 kilowatt hour. This is right. See, this is right. Earlier, I did not. I think I didn't refer the question properly, and I wrote something else. This is it. So this is it. 0.32 kilowatt hour is the energy consumed. Okay, so I have converted 20 minutes into minutes into hours. That's it. That's what I have done. Nothing else. Okay. Now let us see the electrical cost of electricity. Cost of electricity is electrical energy consumed into power charge. So power charge Power charge is nothing but this. This is the power charge that has been provided here. It is rupees 0.194. So 0.32 into 0.194, just multiply, you will get cost of electricity is 1.124. Okay, cost of electricity is 1.128. Sorry, the 1 rupees 1.128 is the cost of electricity for this only one electrical device here. What is the electrical device? It was electric iron device. Okay, so which has been operated for 20 minutes. So how much cost is how much? If the electrical iron box is operated for 20 minutes, it is around 1.128 rupees. Okay, so I hope you have written. Let us go to the another numerical problem. It's already 1 hour. Okay, I'll try to conclude within 10 to 15 minutes. So let us go to the next numerical problem. So this numerical problem, you can copy it down later on. Now I will not ask you to write it down. So you just listen, that's it. Don't copy it down. So calculate the electricity bill of household for a month for 30 days. Okay. And using the following details, electric unit cost is given around 3.45. Okay. So some household appliances are given here, electrical appliance, their wattage and their usage time. These three things are mentioned in this table. Electrical appliance, its wattage and usage time is mentioned. So 4 ceiling fans, 6 LED bulbs, 1 television set, 1 induction stove. Okay. Wattage of ceiling fan, each fan wattage is 220 watts. Bulb wattage is 15 watts. Television is 250 watts and induction stove is 1800 watts. And usage of each fan is 18 hours per day and 12 hours per day. LED bulb is used for 12 hours per day. Television is used for 8 hours per day and induction stove is used for 4.5 hours per day. Okay, this is the given data. Don't write because already 1 hour is crossed. So don't write. So now, let us consider ceiling fan first. Okay, so ceiling fan power consumption per day for how many fans? 4 fans with wattage is how much? 220 watts and they are operated for around 18 hours. So what is the energy power consumed or energy consumed? Power consumed or energy consumed, I can say. So power consumption per day is how much? 4 fans. 4 into wattage 220 into number of hours 18. So instead of writing power consumption per day, I can write energy consumption. So it is okay. Here instead of writing power, I might have written energy. I have written here power. So 4 into 220 into 18, you just multiply. You'll get this in watt hours. You just convert it into kilowatt hours. Divide by 1000, you will get 15.84 kilowatt hours. Okay. So consider it as equation 1. Okay. Consider it as equation 1. Now let's go to the next electrical appliance, that is LED bulb. Okay, let us see the energy consumption per day. There are 6 bulbs whose wattage is 15 watts per bulb and they are operated for 12 hours. Each bulb is operated for 12 hours. So 6 bulbs, 15 wattage and 12 hours operation. So you just multiply all these three, you will get 1080 watt hour. So convert that into kilowatt hour. It is 1.08 kilowatt hour. So consider it as equation number 2. Okay, consider it as equation number 2. Now let us go to the next one, that is TV set. TV set, it's only one TV, so its wattage is 250 watts and operated for 8 hours per day. So one TV, so 1 into 250, I did not write here 1. 1 into 250 into 8. 250 is the wattage, 8 is the number of hours that it has been used. TV is turned on for 8 hours per day. So if you just multiply 1 into 250 into 8, you will get 2000 watt hour. Convert 2000 into kilowatt hour, so you will get 2K watt hour. So consider it as equation number 3. Okay, so what is leftover? Leftover is one more is induction stove. Okay, similar to this, for the induction stove also we can calculate the energy consumed per day. Okay, of course I have written power consumption, but it is energy consumed per day. So for stove, only one stove is there. Its wattage is 1800 watts and it is operated for 4.5 hours per day. So 1 into 1800 into 4.5. So you just multiply, you'll get 8100 watt hour. Convert watt hour into kilowatt hour, you'll get 8.1 kilowatt hour. So consider this as equation number 4. Okay, so we have calculated energy consumption per day for 4 ceiling fans, 6 bulbs, 1 TV set, and 1 induction stove. Okay. So what we are going to do is to determine total kilowatt hour per day for all these devices. Simply add their energy consumption per day. Okay. So for I think 15.84 for was for ceiling fan. 4 ceiling fans energy consumption is 15.84 and 6 LED bulbs it was 1.08 and one TV set it was 2 and for one induction stove it was 8.1. Okay, so just add all these energy consumptions. Okay, fans, LED, TV set and induction stove. Add all those energy consumptions per day. You will get 27.02 kilowatt hour. 27.02 kilowatt hour. Okay, this is for one day. Okay, this is for one day. Now we have to calculate for 1 month. So in the question itself, they have mentioned for 30 days. So they have mentioned for 30 days. So total power consumed in 1 month, total power consumed in 1 day into 30. That's it. Total power consumed in 1 day is how much? 27.02. For 30 days into 30, you will get 810.6 kilowatt hours. 810 kilowatt hour. Okay, that's what you will get. So what is the LCT bill? So LCT bill is total power consumed for 1 month, okay, into cost of one electric unit. So cost of one electric unit, in the question itself, he has mentioned 3.45 rupees. If you see in the question itself, they have mentioned, where is my cursor? Yeah. Electric unit cost is rupees 3.45. It is mentioned in the question. So whatever electrical energy consumed per month in kilowatt hour, you just multiply with 3.45, you will get 2796.57, which is approximately equal to 2797 rupees. Okay, 2797 is the total amount, okay, that has been consumed. Okay, so I will take 10 more minutes and conclude the remaining topic. Okay, 10 more minutes. These are the two numerical problems. If you want, you can go through them later on after this session. Okay, one small topic is left out. I'll conclude that. Next is tariff. Okay, so the electrical energy that is generated in generating stations is delivered to the customers, that is consumer. Consumer means load. Load means one of the load is ourselves, domestic loads. Okay, so these electrical energy which is generated in the generating stations, okay, which is delivered to the consumers. Large number of consumers here you can see, where is my cursor here? To large number of consumers. Those consumers can be houses, they can be industries, they can be some factories or commercial offices, hospitals, okay, institutes and all. Okay, and this electrical energy which is given, it is at a reasonable rate. Yeah, that electrical energy is given and we know we pay electricity bill daily. Sorry, not daily, monthly. Okay, so we pay electricity bill monthly. So whatever rate that is fixed, Okay, that is reasonable rate. So what is meant by tariff? Tariff is the rate at which the electrical energy is supplied to the consumer. Okay, the rate at which electrical energy is supplied to the consumer is known as tariff. Okay, so what this tariff includes, let us see. So tariff inclusions. Tariff should include recovery of the cost of generating electrical energy in power stations. See, to generate the electrical energy in the power stations, see, this is it. If you see in this image, this is our power station. So many people will be working here. Okay, there are many equipments that are in the power stations which operate to generate the electrical energy. Okay, so whatever an amount money that has been spent to generate the electrical energy, that has to be recovered. So investment, whatever they invest to generate the electrical energy, that has to be recovered. So what does this tariff include? The recovery of the cost of generating electrical energy in the power stations, recovery of the cost of capital investment in transmission and distribution. So after generating the electrical energy, it is transmitted. Okay, so for transmission, you can see transmission towers and transmission lines. Okay, so these sort of towers you might have all seen. Okay, you people might have seen transmission towers. So for transmission purpose, okay, so there it has to be transmitted to what? To the factories, to the rural villages, to the offices, to the towns. You can see in this image. Okay, this electrical energy which is generated, that is to be transmitted, and that electrical energy has to reach the towns, to the offices, villages, farms, and factories. Okay, so it has to reach all these load sectors. For that, we have to transmit the electrical energy using transmission lines and towers. Okay, so that cost is also to be recovered. And the recovery of the operational and maintenance of the supply of electrical energy. So we need many in between for transmission, for transmitting the electrical power. In between, some devices will be there, such as transformers. Okay, so which will step up the voltage at the generating station, and these transformers which are located nearby to the load sectors in the substations, they will step down the voltage. Okay, and even we need some protective devices. Switchgear system is also provided, which is not mentioned in the syllabus, of course, but we need some switchgear protective devices to keep all these electrical equipments in running condition during unhealthy situations, that such as whenever falls occur. So to protect them against the falls, uh, we need some protective device. So whatever cost, operational cost and maintenance cost, okay, again and again we have to check whether these appliances are working properly or not. Okay, if they have aged or not, all those things. So that cost is also be recovered. Okay, and a suitable profit on capital investment. So whatever they are investing on that, they must have some suitable profit. So all these things are included for tariff. Okay, so what is tariff? What is tariff? Tariff is the rate at which the electrical energy is supplied to the consumer. So the rate is how this rate is decided. The rate of electrical energy supplied to the consumer is decided by including all these. Okay, what are these? These inclusions. All these are included. Okay. Next, two-part tariff. Okay, two-part tariff. Okay, two-part tariff. There are different types of tariffs. Two-part tariff is one among the different types of tariffs. Okay, two-part tariff is one type of tariff. What is two-part tariff? Simply, it is one type of tariff. So we are not going to discuss all types of tariffs. only I'm going to basically discuss about this two-part tariff. That's it. After that, I will conclude. So the consumers or the customers, okay, consumers who have appreciable maximum demand, for them two-part tariff method is employed. Okay, so the who are the consumers? They have maximum demand of electrical energy. They are the industries. Okay, so here you can see here in this image, these are the factories, and even in railway stations. If you see in railway stations, I'm just searching for industrial consumers. See, the industrial consumers, they are very most important load for the who pay more amount. Okay, when compared to domestic. Okay, domestic means when compared to us. Okay, when we are using electrical energy in our houses, when compared to us. Okay, so these are the more important people. So who are important people means the factories are more important. The work uh, means electrical appliances which are used in the factories. Some of the electrical appliances they may operate for 24 hours. Okay, so they pay much more than what we pay for the electrical energy consumed. Okay, so the consumers who have appreciably maximum demand. So even in railway stations, you see there will not be power cut in railway stations. So maximum demand is required in railway stations and in industries. Okay, so for such people, two-part tariff is employed. So when the rate of electrical energy is charged on the maximum demand of the consumer, then the unit consumed is called as two-part tariff. Okay, so for maximum demand, if the demand is maximum, for such maximum demands, if the rate of the electrical energy is charged, then that is known as two-part tariff. I hope you have understood. Okay. I hope you have understood. If you have not understood, just go through this once. You may be able to understand. Okay, I will conclude within 5 minutes. Okay. So in this tariff, that is two-part tariff scheme, the total cost charged, there is my cursor here. The total cost charged to the consumers consists of two components. Okay, there will be two parts, two components. One is fixed charge, other one is variable charge. Two charges will be there for such consumers who have maximum demand of electrical energy. Oh, okay. So one of the example is the industries. Okay. So this two-part tariff will have two components. One is fixed charge and variable charge. Variable charge, you can call it as running charge. So the total cost will be having fixed charge plus variable charge. You can write it as A in kilowatts plus B in kilowatt hour. What is A? A is the fixed charge. Okay, charge per kilowatt of maximum demand. What is B? B is the variable charge, charge per kilowatt hour of energy consumed. Okay, so A and B are not same. So this two-part tariff will have two components. One is fixed charge, another one is variable charge. So fixed charge, you can represent it by notation A, and its units are kilowatts, and variable charge is in kilowatt hour, that is denoted by B. So what is A, what is B? It is mentioned here. Okay, now the total cost charged, okay, total cost charged by the consumers is obtained by simply multiplying number of units consumed and rate per unit. That we have already done in the previous example that I have shown you. That's what we usually do. So now the fixed charges will depend upon maximum demand of the consumer, and running charge will depend upon energy consumed. Okay, how much electrical energy they need. Okay, minimum they will just inform the generating stations that this much amount of electrical energy we definitely require per month. Okay, so if they inform them, depending on that, based on the consumer's demand, they will supply that amount of electrical energy. Okay, so and the running charge will depend upon how much electrical energy that has been consumed. Okay, next, fixed charges are due to the generation, transmission, and maintenance. Okay, so how much is, if one power station is there, it will have its own generating capacity. Okay, how much it is able to generate, it is how much it is able to transmit, and how much amount, how much it has to spend in rupees for the maintenance of generation and transmission. All these things are considered for fixed charge. Okay, so if we have the electrical bill with you, okay, if we have the electricity bill with you, I hope by looking at this you are able to understand. So you can see some, there will be mentioned somewhere. Okay, by you just search on this sheet. This amount which I am showing you here, this is the fixed charge, and these are the variable charges. Okay, so and the taxes and penalties. So in this order, they will give us the bill. Okay, but usually we won't even look at the all these charges. We simply see what is the total amount that I have to pay. For example, in this here it is mentioned 3,299. This is what we look at, and we pay the electricity bill. So we won't bother for the fixed charge, variable charge, taxes, and penalties. Okay, so but there will be fixed charge and variable charge for the industries, not for domestic people. Okay, for us, there will not be any what to say, fixed and variable charges. But for industries, okay, who have maximum demand, who require the electrical energy at very huge quantity of electrical energy, for them, two-part tariff is implemented, not for us. Okay, that's it. I will just okay, I will just forward the link in the chat box for attendance. I will just see. So if you have any issue regarding this attendance, just mention in the chat box. Fill the attendance sheet. If there is any issue, mention in the chat box. So I am able to open the link. Just give the attendance and you can leave the session if you have given the attendance. If you have filled the Google form, there is an error. Is there any error? For everyone, error is there. I am able to open. If there is anything else, link does not work. It's not working. For me, it is working actually. So is it asking something else? Even in last session also, the students had some issue. I received some mail, and when I gave them the access, they were able to fill the Google form. Yes, ma'am means what? There is an issue. It's not working. Is it working or is it not working? Not working. Okay, I will see. For me, I am able to open the link. I don't know why. This is it. Okay, once again, I will forward and let me see. This is the link. Let me check. Is it opening? Document is not published. That's what it is showing. Okay. Okay, then I will give you some other link. Wait. For me also it is showing error. Maybe. Okay. I'll forward the previous one. I'll forward the previous one. Previous attendance sheet. Uh, this was the previous attendance sheet. And where is it? Yeah. Yeah, it's not working. For me also it did not work. So let us see whether this will work. I'll just click on this. Ah, yeah, it is working now. This attendance sheet is working. You just check this. You just check this. I will receive an email from you people if you try to give the attendance similar to the previous session. Earlier, the last time also I have received not published. No, last time also same form. I have sent the same Google form. I'm able to open it. I hope you are able to see it on the screen. No, I don't want this. Huh? Oh, no, no, I don't want this. Where is it? This sheet? No, no. I'll remove this. This is not. I'll remove this. I'll send you one more sheet. I wanted symbol 10. Where is it? Not this. I think I lost it somewhere. It's okay. It might be there somewhere in my. No, I'm unable to find it. Okay, 1 second. I will check it in my mail. Then I think I took class on 10th. And see, this is here somewhere. Yeah, this is the link. I'll share this link. Now check, is this opening? Is this opening? Is this link working? Previous session link. Same link I have forwarded. Yeah, I think it's working. Okay, I will just, I will receive an email if you, okay, yeah. Okay, till now I have received approximately 4 to 5 responses, approximately 6 to 7. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 responses I have received. So this link is working. People just click on this new link. Older links, if they are available, I will just delete it. This is working. This one is working. You people can. If you are given the attendance, you just leave the session. You can leave. Okay then. Okay, if you have completed, you can leave. You can note down the numerical problems later on in your notes. I'm still waiting for the Google Forms. So I'm receiving some email from you people. So I'm giving access to fill the Google form in my email. So later on, you can go through this lecture and note down what is meant by tariff and two-part tariff in your notes and note down the numerical problems. If you have given the attendance, if you have filled the Google form, you can leave the session. just I will wait for 5 more minutes, and if no responses in my mail, then I will just close this session. I'm just waiting for the responses in my email. Okay, I will conclude then. I'm going to close this session. I hope no one is left over. Here, concurrent viewers, it is showing 0. So I'm just going to end this stream.